I'm using Sklearn's powerful IterativeImputer tool to handle missing data. It's a super cool way to fill in blanks using iterative methods. I have a dataset with 3 features, A, B, and C. Feature C has some missing values. We need to figure out how to fill them in intelligently. I'm using the IterativeImputer with a linear regression model as the estimator. This means the imputer will use linear regression to predict missing values. The first step is to use linear regression. I predict the missing values in feature C using features A and B. Think of it like this. I'm finding a line of best fit to predict C based on A and B. Next, I refine these predictions. Because I've now filled in some of the missing values in C, I can improve the prediction by using this newly imputed data in the next iteration. I repeat this process multiple times to reach a good estimate. Finally, I have a complete dataset where I've filled in the missing values in C based on the iterative process and predictions from A and B. This refers to one of the features in my dataset. Another feature in my dataset, used to help predict missing values in C. The feature with missing values that I'm trying to impute, fill in. I see this statement as absolutely correct, because the iterative imputer works iteratively. The order you fill in the missing values influences the model's next steps. Think of it like a chain reaction, each step depends on the previous one. Therefore, a different order would lead to distinct outcomes. I'd say this statement is incorrect. The iterative imputer cleverly handles missing values in all features simultaneously, iteratively filling them in. It doesn't need every single value to start. It uses what it's got and updates the model step by step. This is definitely false. The whole point of the iterative imputer is that it refines its predictions in a loop. It's not a one-shot deal using a single model fit on all available data. Instead, it updates its model in each iteration. This is simply asking you to identify the correct statements from the previous multiple-choice questions. You must decide whether the statements are true or false based on your understanding of how the iterative imputer functions. I see feature A as one of the features used to predict the missing values in feature C. The iterative imputer uses a linear regression model, and feature A is an input variable in that model. Think of it as one piece of the puzzle used to fill in the gaps in feature C. Similar to feature A, feature B is another input variable used in the linear regression model to predict the missing values of feature C. It works together with feature A to provide information that helps the model predict the missing data. The model cleverly combines both features to do a better job of filling in those blanks. Here is the target. Feature C is the feature with missing values that the model wants to impute. Using the available data from features A and B, it is the outcome that we are trying to predict. These are the values that iterative imputer calculates to fill in the missing data points for feature C. It's the result of the model's prediction process. Think of them as the model's best guesses, based on the information given by feature A and B. I'm using Sklearn's IterativeImputer to fill in missing data. Specifically, I'm using linear regression to predict missing values. That's like saying, I'll use the relationships between my known data points to guess the missing ones. I have 3 features, A, B, and C. Feature C has some missing data points. I'll need to estimate those. I'm going to start filling in the blanks. Think of it as a puzzle where I need to make educated guesses based on existing data. I'm setting up my IterativeImputer tool. I've chosen linear regression, meaning I'll predict missing values using linear relationships among known values. I'll predict the missing C values using known A and B values. Importantly, I'll repeat the process, updating my predictions using the newly imputed values of C until the values stop changing significantly. Convergence. This is why it's called iterative. I'm going to improve my predictions through many rounds. I continue to refine my predictions based on previously imputed values until the difference between successive imputations is minimal. This process is iterative, hence the name. The order in which I deal with the features is important because I'll use the already imputed values to improve future imputations. Changing the order will likely give me different results. My final output is the original dataset but with the missing values in feature C filled in using my iterative linear regression method. I see that feature, C, has a lot of missing data points. This is the problem we're trying to solve using the IterativeImputer. We'll use the other features, A and B, to predict the missing values in C. I'm using Sklearn's IterativeImputer to fill in the gaps. It uses linear regression, which means it will try to find a straight line, or a plane. In this case, since we have multiple features, to represent the relationship between features A, B, and C. The cool part. It does this repeatedly, improving its predictions each time. In the first step, I'll use the existing data for A and B to predict what the missing values of C should be. I'll fit a linear regression model using only the rows where all values A, B, and C are present. After the first guess, I'll rerun the linear regression model. This time, I use the predictions I just made for C from the previous iteration, together with the existing data. That's the iterative part. This refined data gives us even better predictions for the missing C values. Because the imputer uses the previously imputed values to make future predictions, the order in which I process the features, A, B, then C, or some other order, changes the final results. I'm using Sklearn's IterativeImputer, a tool that cleverly fills in missing data. It does this by using a linear regression model iteratively. Think of it like this. It makes a guess at the missing values, then uses those guesses to make better guesses, repeating until the guesses stop changing much. The core of this process is an iterative refinement of predictions based on the previous iteration's output. This is the heart of the matter. Iterative imputation means we repeatedly improve our estimates of missing values. We start with an initial guess and then refine that guess using additional information. Each iteration refines our understanding further. It is like solving a puzzle. I make my initial guess and then I add additional pieces to the puzzle, eventually resulting in improved guess accuracy. In the first step, I predict the missing values in feature C, using features A and B. I'm using the data I already have to make an initial guess for the missing values. It's like having a few puzzle pieces and using them to anticipate the shapes of other missing pieces. Now, I use the values I just guessed in step 1, for C, along with features A and B, to make an even better guess for the missing values in C. It's as if I found a few more puzzle pieces to improve my guess about the missing ones. I keep repeating this process until my predictions for the missing values stop significantly changing. This is called convergence. My guesses have become stable. It is like finally completing the entire puzzle with all pieces fitting snugly into their place. This means I've reached a satisfactory solution. I'm using linear regression to model the relationship between my features. Linear regression finds the best fitting line, or plane in multiple dimensions, to predict one variable based on others. The estimator is the tool, in this case, the linear regression model, that I use for prediction at each iteration. Finally, I have a complete dataset where all the missing values in C are filled in with estimates from our iterative process. I have a finished dataset ready for further analysis. I'm working with data having features A, B, and C. Critically, C has some missing values, which I need to fill in using my IterativeImputer. This is the initial dataset I start with before the imputation process begins. I start the imputation process. I use features A and B, which have no missing values, to build a linear regression model to predict the missing values in feature C. I'll use this model to make my first guess at filling in the gaps. I use a linear regression model where features A and B are the input and feature C is what I'm trying to predict. Think of it like this. I'm finding a line of best fit to show how A and B relate to C. I use this line to guess the missing C values based on the values I already have for A and B. I use the predictions from the linear regression model to fill in the missing values in feature C. This is my first imputation step. I repeat the process, this time using both the original data and the imputed values from the previous iteration. I'm refining my guesses. I keep doing this until, after my first guess, I use the values I just imputed for C along with A and B to improve my model. I'm basically saying, Okay, I made some guesses. Let's see if I can improve them by using those guesses as if they were real data. I check if my predictions have stopped changing much. If my changes are tiny, then I've reached a good enough solution. If I've reached a stable solution, that is, after multiple iterations, the imputed values don't change significantly, I'm done. I have my final imputations for feature C. If my predictions keep changing significantly, I continue with more iterations, step 11 and 12, until I reach a stable solution. I've completed all the iterations. I have a dataset where all the missing values in feature C have been filled in using the iterative process described above. The entire dataset is ready to use.